Good evening. My name is Jose Jimenez, and this is my, we'll say, video for this interview to obtain a position at, we'll say, the College of Philadelphia. I've been teaching for quite a while. One of my favorite platforms is online teaching. I do have my own YouTube channel that I provide to my students so that they can, we'll say, see pre-recorded lectures and for me to answer additional questions that they might have. So I've been working with, we'll say, this platform for a very, very long time, roughly, I want to say 5 or 6 years teaching online, and in total, 11 years teaching. The topic that I picked today is going to be adding and subtracting, we'll say, fractions. It's we'll say, one of my pet peeves. I teach both at the high school and at the college level, and I see lots of, we'll say, difficulties with my students with fractions, and that should not be something that hinders them. It should be something that they appreciate, something that they understand, something that they will say enjoy. Um, so without further ado, let's go straight into we'll say my Paint. This is my Paint program. I use this for most of my lectures at any school. All right, so adding and subtracting fractions. All right, so let us start off with a general fraction. So let's say we have A divided by B plus C divided by D. So the main idea of adding fractions, we're going to need some level of a common denominator. That is one of the most important things we're going to need to add any fraction or even subtract. We need a common denominator. So the way we're going to obtain that is usually you want to look for something called the least common multiple or least common denominator, because uh, that will allow us to get the denominators to be the same. Now, I know a lot of you probably had um, a lot of you worked with fractions before. Let's review the portions of a fraction. That's the most important thing, understanding what we're looking at. This right here, the A and the C, this is the numerator. It is a thing that goes on the top of your fraction. And knowing that it's a numerator is very important, because if you don't know the terms, then how are you going to um, understand the, we'll say, the material? So the numerator is, we'll say, of course, the top portion of the fraction, and the bottom portion, the one that I'm about to circle in purple, this right here is your denominator. Now, one thing that I always like to jokingly say, well, your denominator is the one that holds up the fraction. Without the denominator, you're just going to have a whole number. The numerator, that is the thing that's on the top. That is your head, and then the denominator is like the bottom half of your fraction. And the most interesting part about the numerator and the denominator we're going to see that the numerator itself is the thing that we're going to always combine together. Now, this is the thing that's going to be added together usually. So if we go to we'll say numerical example, if we have 1/2 plus 1/2, this right here, since the denominators are the same, we can rewrite this fraction as 1 plus 1. I'm only going to deal with the numerator. As long as the denominators are the same, I can add across the top. Let that sink in for a bit. As long as the denominators are the same, I can add straight across from the top. If the denominators are different, I'm going to have a different approach. And we're going to cross that bridge eventually. But the main idea that I want you to see, I want this purple thing that I circled, which is called your denominator, I want those to always be the same. No matter what I'm doing, it has to be the same, or else I cannot combine those fractions together. So what we're going to see is we're going to, we'll say, have two methods to solve our problems. The two methods is if we have the, we'll say, same denominator, just touch the numerator. Write it as a single fraction and just touch the numerator. If we don't have a common denominator, well, we're going to have to get a common denominator. And that's when we're going to have to see that although we're adding or subtracting, we're going to have to bring in multiplication. Multiplication has to come into the mix. So we can call this the first way of adding and subtracting our fractions. As long as we have the common denominator, we can easily translate it into this. And if we want to look at it in a general sense, if we have A and we have C and they have the same denominator, it's always going to be A plus C over B. And we're just going to combine the top together. But if we encounter a scenario where the denominators are different, we're going to have to tackle that differently. We're going to have to get that common denominator. And that's when the least common multiple is going to come into play. It's going to help us transform the denominator into the same number so that we can just combine the top together. And that's a fun process. I think it's a fun process. I really enjoy it. It's we'll say one of my personal favorite things to do in mathematics is playing around with fractions. Fractions I think are better than decimals will ever be because you can use you can get a simplified fraction and then you can work with simplified fractions forever and you're happy. It's like pizza. Pizza, that's always going to be a fraction. You always want that one slice of pizza, and yeah, unless you want to eat the whole pie, which I've been known to do, but a single slice of pizza is amazing. All right, so let's go back to that one problem where we had the common denominator. We had the 1 plus the 1 over the 2. That's going to transform into 2 over 2. And some of you might have seen this before, that is just going to be the value of 1. But if we leave it as a fraction, it's 2 over 2. You could also, we can also express that as 1, but 2 over 2, I think that's pretty cool too. Now, if we have a fraction that has a different denominator, let's say 1/3 plus 1/4, well, what we're going to do here is we need to find the least common multiple. At this stage, the best way to find that is to just take the denominator of the first fraction and multiply it by the denominator of the second fraction. And what I mean is this. We're going to take... Oh, whoa. I think I stopped sharing. Let me go back to that. My apologies. We're going to take the first fraction and we're just going to multiply it by 4. That's all we're going to do. And then we're going to keep this in our head. Whatever we do to the bottom of the fraction has to be done to the top. If I multiply the bottom number by a number, I have to multiply the top by that same number. So that it remains to be the same fraction. A lot of you probably saw simplification in your career, but simplification is usually when we're dividing it out. When we're looking for that least common multiple, we want to do the reverse of that. To do the reverse of that, we have to multiply. So if I multiply the bottom by 4, the top has to also be multiplied by 4. And now for the second fraction, what I'm going to do is I'm going to do the same thing. I'm going to take that number that I know, which is on the opposite fraction, which is a 3, and I'm going to multiply that 4 by that 3. And I'm going to say to myself, oh, wait, I multiplied that by 3. Let me multiply the numerator also by 3. Let me multiply the top value by that same 3. And that is the beauty for mathematics. A lot of you probably went through, we'll say, a few courses in algebra in high school or in middle school, and you saw that when we're dealing with pre-algebra or algebra, you have to take the number and subtract it from both sides, and you do it to both sides. It's the same thing with this. You could think of this as the denominator as one side and the numerator as another side, so that you have to end up being consistent with your mathematics, to be consistent with it, which is a cool thing. All right, so I'm going to multiply the top one by 4. And then multiply the top one by 4. Hold on, let me make sure I pick a different color. I'm going to get, let me pick a color that doesn't, we'll say, hurt the eyes. We're going to get a 4 on the top and then a 12 on the bottom. And over here, we're going to get a 3 and a 12 on the bottom. And now, the cool thing is, all we did was got the common denominator. We transformed our fraction to look like a different number, but it's still evidently the same fraction. If we simplify both these fractions, we're going to get back 1/3 and 1/4. So we're still doing a process that we've seen before. And the cool thing is, once we get to this level, we jump back to number 1, which allows us to say, oh, wait, the denominators are the same. I'm going to rewrite that as a 12 in my denominator and 4 plus 3. And the cool thing is, we already know what 4 plus 3 is. 4 plus 3 gives us 7, and we get 7 over 12 as our answer. And that's how we combine fractions of unlike denominators. And this is how we combine fractions of like denominators. So what we can see is common denominator. And over here, we're going to see it's a non-common or not common denominator. But the not common denominator ends up becoming the common denominator after we do it. So it's just an extra small step that we need to do. And that's the way mathematics works, even from the level that I work with mathematics to the level that you're currently receiving the mathematics. You're going to see that all we're doing is adding an extra bit of we'll say, icing to our cake, or extra layer to our cake, which is amazing. We're seeing this, uh, and this is what we're doing when it comes to mathematics. We're always constantly not inventing new mathematics, but adding extra things that we know and love. And uh, I think that's pretty cool. All right, so one thing that we're definitely going to see is when it comes to subtraction, it's going to be the same exact thing. When it comes to subtraction, we're still going to do the same thing that we were just doing. However, what we're going to see is it's just going to probably bring in some integer values. We might end up with some negative numbers. We might end up with some positive numbers. Subtraction is important. Wherever we have addition, there's always subtraction. But it's just a reverse process. When it comes to maths and the sciences, we're always thinking about, oh, if we uh, put these ingredients together and we put it inside an oven, we get our desired, we'll say cake, or we get a desired pie. We have this process that we layer off so that we can create the most important thing, the thing that we desire. And that's all math is, just getting to the thing that we want to understand. When it comes to what I do in my life, I look at I look at the cosmos, I look at stars. I have a very particular strong interest in physics, and one of my favorite things to look at is Proxima Alpha Centauri. When I'm looking at that, I'm looking at how far away it is in light years, or is distance in parsecs. I am just I have a strong appreciation for that, and that right there is just mathematics that I work with. It's orbital mechanics, and we'll say just looking at Lagrangian mechanics and stuff, and it's fun. And I did it every day, and yeah, it's enjoyable. So, but not to get off too much on the tangent, let's just look at subtraction for a quick second, and then what we'll also discuss is when we're adding fractions, what if we have a whole number attached to it? And we probably can't get through that into today's lesson, but that will be what we'll see in the future. Just to see how it works when we bring in a whole number, and then that's pretty fun. All right, so in essence of time, let's just suppose I had 8 over 12 minus 1 over, what's a good number, 2. Well, I'm going to first see is the same exact process. I don't have a common denominator. I have to make sure I get that common denominator. I can just do 2 times 12 and then 2 times 12. So I can times this guy by 2. I could times this guy by 2. And I can multiply him by 12, and I can multiply him by 12. And there might be some of you out there that says, hey, wait, why don't you just use 12? I can, but at this level, instead of making it harder for myself and um, we'll say always trying to search for a common denominator between two numbers that are not the same, uh, I could just multiply them together and still get a common denominator. But at the end, I just have to make sure that I simplify. And remember, there's not always one way to do a problem. So bear with me. We'll do this one method and then we'll start bringing in others as we progress within the course. All right, so 2 times 12, I know I'm going to get 24. And then 2 times 8, I know I'm going to get that 16. Minus, it should be 12 times 1, which gives us 12. And then 2 times 12, which gives us 24. And of course, when I subtract this, I'm going to get, was that 4 over 24? And then all I have to do is just, hey, wait, this guy's even, this guy's even. Why not just divide by 2? So if I divide this by 2, I get 2 over 12. And I could go even further and keep dividing by 2. and I'm going to get 1 over 6. And that will be my final answer, which we probably could have got if I would have just multiplied that 2 by 6. So let's see that in action. We can see that if no matter what way we go, we're still going to get the same answer. So if I have 8 over 12, and let's say I multiply the second fraction by 6, so that's going to give me 6 over 12. And I'm just going to get 2 over 12. And then I'm going to simplify that into 1/6. So no matter which direction I go, I'm always going to get the same answer. And that's the beauty of fractions. Because one thing that you can end up obtaining is a non-repeating, non-terminating decimal. And those are not fun because they're non-repeating and they're non-terminating. They're going on forever. Whereas if I express it as a fraction, it's something that I can handle and deal with. All right. And thank you so much for your time and enjoy your day. Awesome. And not to take too much of all of your time, but math is a big passion for mine. And teaching at a college has showed me a great, we'll say, a great deal of mathematics. And then when I started to work at a high school, when I was teaching physics at a high school and I was teaching mathematics at a high school, it showed me that at the very beginning stages, we can plant a seed and allow the students to flourish and grow into normal adults. And then there were times I had repeat students, and it has been a very big pleasure to, uh, we'll say, help my students along the way. And those repeat students were fun. Whenever I had a student at my Catholic school, when I was teaching at the Catholic school, it was fun. And then when I saw them again in college, some of them I saw them in Moravian University, or I saw them in ESU, and it was like, "How you been?" And it was always good to have that nice connection. And yeah, uh, I know we'll probably cover this in a face-to-face interview. I apologize, and enjoy your day, and hopefully, uh, I'll be seeing you guys in person. Enjoy.